Hi, welcome back to 1.5, solving quadratic equations. In this example, we're just going to make a connection between the number of zeros of a function to the number of x-intercepts on the graph. Okay, so I've color coordinated all three of these equations, green, blue, and red, and I have graphed them already on Desmos app. So these are the three graphs. So as I zoom in here, you can see that depending how the quadratic is situated on the graph, it may or may not have any x-intercepts. So we can see the green graph has 2. We can see the blue graph has none. And we can see the red graph most likely has 1. And if I zoom in, you can see it's always touching just at one point. And we can see that's actually an x-intercept. All right, so in this green graph, I'm going to go ahead, I'm just going to isolate the other colors. Okay, in the green graph, so we would have, the function would have 2 zeros. Okay, we can say here the graph has 2 x-intercepts. Okay, and we'll just list them out right here. We'll say x equal to 0.775, and then the next one is at 3.225. All right, now the blue one, let's turn the other one off. So we can say the function has no zeros. Okay, that means the graph has no x-intercepts. Okay, so and that's very common for this to happen for a quadratic to open upwards or downwards and be above or below the x-axis. Okay, in our last case with the red curve, so you could tell when I zoomed in before, this only just has one x-intercept. That's because the vertex is right on the x-axis. So we can say here, let's say function has 1, 0. The graph has one x-intercept, which is the vertex. Okay, so we can see it's possible to have one solution, possible to have no solutions, and it's possible to have two solutions. All right, now what we're going to do in this next example, example 3, we're going to connect the number of zeros to the quadratic formula. Okay, so it says here, solve each quadratic in example 2 using the quad formula. Give the answers for the x-intercepts as exact values. Okay, so this is kind of new, this exact value part. So something we've just started doing in this course, and something that we're going to keep doing throughout. And what that means is we don't want to put our final answers in the calculator and hit equals, because that answer is an inaccurate answer, because it's been rounded. Um, so we'd rather leave stuff in exact form. And I'll explain a little bit more of that later on. And then we'll just compare them to the x-intercepts that we found in example 2. So I kind of listed them here. The red one, I forgot to write this down, but this one was at x equal to 1.5. That was the other x-intercept for that one. Okay, let's get started. So the one in green, this equation here, okay, let's apply the quadratic formula to it. So this is my A value, my B value, my C value. So yeah, I recommend you don't write too large for this one either, because we'll have to do the quadratic formula 3 times in this one. All right, so subbing in B, we got 8, so we have -8 plus or minus square root 8 squared minus 4 times A times C, -5, all over 2 times A, -2. Okay, let's clean it up a bit. 8 squared is 64. We have 3 negatives here, so we're going to get a negative value. And then 4 times 2 is 8. 8 times 5 is 40, so that all works out to 40. All over -4. -8 plus or minus the square root of 24, all over -4. Now, it's a good thing we just previously had that lesson on radicals. Okay, we're now going to take this radical here, the square root of 24, and we're going to split it up into 2 to simplify it. So the largest perfect square that fits in 24 is 4. So we have 4 times 6. The square root of 4 is 2, so we're going to have 2 root 6. So I want to take this and I want to replace it in for root 24. So we have -8 plus or minus 2 root 6 over -4. All right, so I'm going to clean this up a little bit. So looking back here, okay, I can actually divide out a -2 from all of these to simplify things. Okay, the reason why I'm doing a -2 is because I want to get rid of these negative signs here. Obviously, the plus or minus part is going to become a negative plus part when I divide by -2, so that's not going to change. I can just leave that there, but the 2 will change to a 1. So um, let's do this here. So -8 divided by -2 is going to give me +4. 2 divided by -2 is going to give me just 1. And then -4 divided by -2, that's going to work out to just 2. So we have 4 plus or minus root 6 over 2. So my first solution, now this is going to be exact. It's 4 plus root 6 over 2. This is exact solution number 1. Okay, it's exact because it cannot be simplified any further. Okay, I can divide 4 by 2, but I can't divide root 6 by 2. So this is as simplified as it gets. And if I try to evaluate the square root of 6, well, that's a non-terminating decimal, and I can't possibly write that number out without rounding it. So that's what makes this exact. Okay, we'll do an approximation of this in a second. Okay, so but for now, this is the exact form. My other solution is going to be when we consider the negative part. So let's write that one out. 4 minus root 6 over 2, and this is also exact. Okay. The only reason why I'm going to find the approximates here is because I want to compare them to the graph. So let's type them in. 4 plus the square root of 6, all of that. Let's put the whole thing in brackets. Yeah, and then we'll divide that by 2. And it looks kind of familiar, the 3.2247. I'll round that up to 3.225. Okay, that's my one approximate answer. Okay, and the second one, let's switch that to a minus. We got 0.775. All right, let's compare these to what we got before in example 2. So notice those look a little bit familiar, those x-intercepts. Okay, actually I still have it on Desmos. If we go back, I can turn on that graph. And we can see those right there. Okay, so they're the same solutions that we got by solving the quadratic formula. Okay, I'm just going to compress this. And then we'll start the next one. Okay, we're going to apply the quadratic formula to this one now. I'll switch over to blue. Notice I always write out the quadratic formula every time. I know it's kind of tedious a little bit, but it's going to help you remember it. Okay, so here are my values for A, B, and C. Okay, these are A, B, and C. So I'm just going to plug those in. Right, so B is negative 11, so we're going to have minus negative 11 plus or minus the square root. B is negative 11 again, so negative 11 squared minus 4 times A is 8, C is 5. All of this is divided by 2A, 2 times 8. So we have 11 plus or minus the square root. Negative 11 squared is 121. And then we have negative 4 times 5 is negative 20 times 8, negative 160 minus 160. 2 times 8, down here, that's 16. And you might have seen we kind of run into a problem here, right? 121 minus 160. Okay, that is no good. We cannot take the square root of a negative number. So it's kind of nice. We get to stop here. Okay, the fact that that is negative is no good. We can only take the square root of positive numbers. So we can just stop and we can say no real solution exists. Okay. How did that how does that relate to what we did in example 2? Well, when we graphed this, there were no zeros. The function had no zeros or no x-intercepts. Okay, that's why there's no solution that exists. Okay, this actually was the graph right here in blue. So the vertex was above the x-axis and it opened upwards, so there's no x-intercepts, so there's no zeros or there's no solution. Okay, that always happens when we try to take the square root of a negative number. We get no solutions that exist. Okay, that wasn't too bad. It's kind of nice when that happens. It makes the question a little bit shorter. All right, and looking at the one in red, we only had one solution. Let's go ahead. We'll do quadratic formula and see what happens. Again, this is A, B, and C. All right, B is 12. So we have negative 12 plus or minus the square root of 12 squared minus 4 times the first term, negative 4, and C, the last term, negative 9. All over 2 times A, so 2 times negative 4. Negative 12 plus or minus the square root of 12 squared is 144. Then we have minus, we have 3 negatives, so we're going to get a negative answer. I'll just put a negative there. And then 4 times 4 is 16. 16 times 9, 144. So you kind of see something kind of interesting happens here. 144 minus 144, this is all 0. So negative 12 plus or minus the square root of 0 over negative 8. So this obviously is just 0. The square root of 0 is 0. So it kind of gets rid of this whole last part. And we're left with just negative 12 over negative 8, which equals 3 over 2, or 1.5. Okay, and that was exactly what happened in example 2. We had our x-intercept at 1.5. Okay, and there was only one of them. So it's kind of cool. We only get one solution to the quadratic formula. There's only one way to get one solution. It's when all of this works out to 0. So if you remember at the start of this lesson, I called this the discriminant back in the previous video. So if your discriminant works out to 0, then that's beautiful. You're only going to get one solution. If the discriminant right here, if it works out to a negative number, then you get no solutions. And if your discriminant works out to a positive number, then we're going to get two solutions. Okay, that's it for now, and I'll see you in the next video.